This is an introductory video to right triangle trigonometry and the three basic trig functions that we have. So trig, or trigonometry, first began with just studying triangles, and we took some relationships between the side lengths of a right triangle. Well, we had to identify, so come up with some type of verbiage for those ratios. The first one, we are going to call it sine. The definition of sine is the ratio of the leg opposite to the angle to the hypotenuse of the triangle. So if I want to find the sine, the notation for it will be sin. You'll be able to find that button on your calculator, and then the angle that you're trying to find the sine of. So if we say the sine of angle A, we're going to identify where angle A is at, then where the side opposite of A is, and the side for the hypotenuse, which will always be directly across from the 90-degree box. So our ratio here will be A over C. If I want to find the sine of angle B, identify where angle B is, so we know where the side opposite of the angle is, and then the hypotenuse, so the sine of angle B will be B over C. The second trig function that we have is called cosine. Cosine is defined by the ratio of the leg adjacent to the angle and the hypotenuse. So the labeling for the cosine is we're going to use COS, and you'll also be able to find that button on your calculator, and then the angle that you're trying to find the cosine of. So cosine of angle A, identify the angle. Adjacent is the side length that touches the angle, so that's B over the hypotenuse, so then we will say that's B over C. If I want to change the angle and do the cosine of angle B, identify the angle. This time the adjacent side is side length A, and still using the hypotenuse, so its trig ratio will be A over C. Third and final trig function that we will discuss today is tangent. Tangent is defined as the ratio of the leg opposite of the angle to the leg adjacent to the angle. And it is labeled with TAN, looks like tan, but we'll call it tangent. And once again, that button will also be on your calculator and the angle that we're finding the tangent of. So we identify the angle, find the side opposite, and then the side adjacent to angle A, and its trig ratio will be A over B. Change the angle, we change the opposite and the adjacent. So angle B, side opposite is side length B, and the adjacent is side length A. So its trig ratio is B over A. So we'd like to be able to memorize these trig functions and the ratios because we will use them quite extensively throughout this course. We come up with a really nice mnemonic device. That mnemonic device is SOHCAHTOA, where each letter stands for one, the trig function, and the side lengths of the triangle that go with it. So we have sine is opposite over the hypotenuse. Ka is cosine, which includes the adjacent over the hypotenuse, and toa is the tangent, uses opposite over the adjacent. Memorize this, you'll have those trig functions down extremely fast. And now let's apply that mnemonic device and these trig functions. So we're going to look at a right triangle, and we're going to write the trigonometric ratios for each angle that we have of our right triangle. So let's take a look at our right triangle in our example here. We have a right triangle with legs 12 and 5 with a hypotenuse of 13. And we're going to find the sine, cosine, and tangent of angle A and C. So we'll start with angle A. Well, I need to identify where angle A is. There we have angle A. So we know that the opposite side of angle A is 5. The hypotenuse will be 13. So it's the sine of angle A will be 5 over 13. Cosine, since it's adjacent over hypotenuse, the adjacent side will be 12. The hypotenuse will be 13. So the cosine of angle A is 12 over 13. And then finally, tangent for A, using opposite over adjacent, we have our opposite side, we have our adjacent side. So the tangent of angle A is 5 over 12. Moving on to angle C. Now that we have angle C down here in the bottom, we know that the opposite side will be 12 and our hypotenuse will be 13. So the sine of angle C is 12 over 13. The cosine of angle C, we have the adjacent side of 5 and the hypotenuse of 13. So the cosine of angle C is 5 over 13. And then for the tangent, opposite side of tangent is 12. The opposite side of C is 12. The adjacent side of C is 5. So the tangent of angle C is 12/5. So these are pretty simple and nice and easy when you have all three sides of the triangle. But what's going to happen if I don't give you all three sides to the triangle? We need to figure out that third and missing side. And for this, we're going to use Pythagorean theorem to find out that length. So we can use our 9 squared plus 12 squared equal to y squared to find the hypotenuse. Typing into the calculator, we got 9 squared plus 12 squared to give us 225. And then we can just simply square root both sides to get a length of 15. So now that we have that hypotenuse value, and then we can go in and use our trig ratios. So starting with the sine of W, identify your angle, knowing that the opposite side over the hypotenuse will give us the sine of angle W. But this time the fraction is unsimplified. We're going to go in and find out what's the largest number that divides into 12 and 15, which is 3. That would simplify down to 4/5. The cosine of angle W, we've got our adjacent side, we have our hypotenuse, so that's 9/15. Again, this is a fraction that can simplify, which we've reduced down to 3/5. And then the tangent of angle W, we have the opposite over the adjacent, 12/9, a third fraction that can simplify, which reduces down to 4/3. And we're going to do this again for angle X. So now that we have our angle down here, we need our opposite side over the hypotenuse for the sine, 9/15, and then that is another fraction that can simplify to 3/5. The cosine of angle X, we have our adjacent over the hypotenuse, 12/15, or in other words, 4/5. And then finally the tangent, opposite over adjacent, 9/12, or simplified to 3/4. And we have our trig ratios for that, for both of those angles of the right triangle. All right, so how can we use these trig functions to find a missing length, a length of a trig, or of a triangle using trigonometry? Well, there's two pretty simple steps that we're going to do. First, you need to identify the trig function that corresponds with the given sides and the angle that's in the triangle. And then second, we're going to set up an equation and we're going to solve for that variable. Let me show you how this works. So we're going to solve for x, and then we're going to round our answer to the nearest 10th. Here is our given triangle. Well, I noticed that here is my angle, and if I look at side length x, that is considered the opposite of the angle, and 19 is considered the hypotenuse. So I ask myself, which trig function uses opposite and the hypotenuse? That trig function would be sine. So we set up our equation like this. Sine of 28 degrees equals my opposite side, which is x, over 19. So then we use our algebra skills. How do we get the x by itself? Well, we're going to do that by multiplying both sides by 19, which gives us the equation 19 times the sine of 28 degrees. Well, here we go to our calculator. We'll type in 19 times the sine of 28 degrees, which will spit out the value of 8.9. So the length of that leg, opposite of 28 degrees, is a value of 8.9 rounded to the nearest 10th. Let's try a couple more. Here we have another right triangle with our angle 41 degrees. This time the side x, again, is also the opposite side. However, 32 would be considered the adjacent side. So which trig function would use the opposite and the adjacent? That trig function would be tangent. So when we set up our equation, we have a tangent of our angle equal to the opposite over the adjacent, x over 32, and we solve with similar steps. Multiply both sides by 32, and then go to our calculator, type in 32 times the tangent of 41 degrees, and the value of the leg opposite of 41 degrees would be 27.8. Excuse me. The one and final example with the right triangles, before we go into a word problem. Again, identify our angle. 36 would be the adjacent side. X is the hypotenuse. So which trig function would use the adjacent and hypotenuse? This would be cosine. But this time when we set up our trig ratio, my variable happens to be on the bottom of the fraction as opposed to the top. So as we work through this, we still want to use similar steps. Multiply both sides by the denominator, in order to get that denominator to cancel out. And then from here, we need to get this variable by itself. So think back to our algebra classes. If I wanted to get the variable by itself and there was something multiplied to it, we would have to divide both sides by a number. Cosine of 43 degrees is a number, so we divide both sides by it. And we're going to type into the calculator 36 divided by the cosine of 43, and that will tell us the length of the hypotenuse of this triangle. That length is 49.2, rounded to the nearest tenth. So again, we want to use this with, or have some type of application for this, and here we're going to look at one word problem that has an application. Here we have a ramp. It's used to load suitcases up onto an airplane. The cargo door is 7 feet from the ground. The angle formed by the end of the ramp, the very tip of it, going up from the ground, is 25 degrees. How long is this ramp? Well, let's get an illustration in here. Here's my right triangle. The hypotenuse would represent the length of the ramp. We have the height of this from the cargo door down to the ground is 7 feet, so we got that leg of the triangle. We have the angle that was formed from the ground, and then finally, we don't know the length of the ramp, so we're going to label that X. So having this picture, it's giving us a chance to at least identify what are the relationships between the side lengths to the angle. Well, my angle's down here. We see that 7 is opposite. We see that the X is the hypotenuse. So opposite and hypotenuse would lead us to sine. We're going to use sine to set up this problem and solve. So we have sine of 25 degrees equals our opposite over the hypotenuse. Similar to our previous example, we multiply both sides by the X to cancel out, and then divide both sides by the sine of 25, and then we go to our calculator, type in 7 divided by the sine of 25, and the length of this ramp is going to be about 16.6 feet. So there's your short introduction to the trig ratios of sine, cosine, and tangent and their application.